Hi everyone, I'm Chudashni. Today we are going to see about Strassen's matrix multiplication algorithm. Let's see what is meant by it clearly with our lab experiment programs. Let's start with the definitions. One of the easiest concepts in DAA is Strassen's matrix multiplication algorithm. The definition of the Strassen's matrix algorithm is it is a method used to multiply two matrices in a faster way. Compared to the normal matrix multiplication, it reduces the number of multiplicants, which makes it more efficient. Let me say that what is the need of Strassen's matrix multiplication. Now, why do we need this algorithm? In the normal method, for a 2 cross 2 matrix, we perform 8 multiplicants. But multiplication takes more time compared to an addition. So, Strassen's algorithm reduces the multiplicants from 8 to 7, which improves the overall performance. This is the need and why should we use the Strassen's matrix multiplication concept. Let's start with an algorithm. Now let's see the algorithm step by step. First we take two input matrices A and B of size n into n and we need to find the result of matrix C. For the step 1, if the matrix size is 1, that is only one element, we directly multiply the two values and return the result. For divide, if the matrix size is greater than 1, we divide both matrices into 4 equal submatrices. So matrix A becomes A11, A12, A21 and A22 and matrix B becomes B11, B12, B21 and B22. For the third step, we are going to the compute 7 products. Next, we calculate 7 intermediate values. For P1, P2, P3, P4, P5 and P6 and P7 will be the formulas. Here, instead of doing 8 multiplication, we are doing only 7. Finding results of the submatrix, now we use these values to compute C11, C12, C21 and C22. And the combined step will be, finally we combine C11, C12, C21, C22 to form a final result matrix C. So this is how Strassen's matrix multiplication algorithm works using divide and conquer to reduce the number of multiplication. This will be implemented using the program. Next, in the next slide, we will see how it works and how it performed as step by step. Let's see how Strassen's algorithm actually works. Instead of directly multiplying all elements like the normal method, this algorithm works in a smarter way. First, it breaks the big matrices into smaller parts. So one big matrix becomes 4 smaller matrices. This makes the problem easier to handle. Next, instead of doing normal multiplication, it creates 7 special combinations of these smaller matrices. These combinations include addition, subtraction, multiplication. Because of this trick, we reduce one multiplication. Now why it is important? Because multiplication takes more time than addition and subtraction. So even though we do more additions, reducing one multiplication makes the algorithm faster overall. After calculating those 7 values, we recognize them in a specific way to get the final result matrix. So basically, we used to divide the matrix, so smart calculation in 7 products, combine the results. This is the concept, how it works in Strassen's matrix multiplication. In the next slide, Strassen's 7 products and combined products will be listed. Let's see what is it. These are Strassen's 7 products and combined products. As we discussed, these formulas in the algorithm part are same as 7 products and combined products. Now I will explain a diagrammatic representation of a Strassen's algorithm. First, in the diagram we can see that the given matrices A and B are divided into 4 smaller submatrices. So matrix A is divided into 4 parts and matrix B is divided into 4 elements. Here you can each block in the diagram. You can see each block in the diagram. Next, from these submatrices, we compute 7 intermediate products shown as P1 to P7 in the diagram. Each P value is calculated using a combination of addition, subtraction and multiplication. This is a key part of a diagram because we are reducing the number of multiplications from 8 to 7. After that, the diagram shows how we compute the result matrix paths as C11, C12 and C21, C22. These are formed using the values from P1 to P7 as a final blocks. To say that it's clearly, so the diagram shows how the matrix is divided, processed using 7 products and then combined to get the final result. This is a representation of working of a Strassen's algorithm. As I had run the Strassen's true matrix in the VS Code, I had displayed the screenshot of the program which I had run and executed. Let's start my program with a smart explanation. Okay, first the program starts with taking two input matrices as A and B from the user. These matrices are stored in 2D arrays. Next, the function of Strassen's multiplication is called. Inside the function, the program first checks the base condition. If the matrix size is 1, it directly multiplies the element and returns the result. If the size is greater than 1, the program divides the matrices into 4 submatrices A11, A12, A21 as same we see in the algorithm. After dividing the program, calculates the 7 intermediate products P1 to P7 using recursive calls. Each P value is computed by calling the same function again with smaller matrices. Then, using these P1 to P7 values, the program calculates the result submatrices. Finally, these submatrices combined into a single result matrices, which is the final output. I will show the output in the next slide. While executing the program, I get the output as enter elements of matrix A as first. Next, I had given the input of 4 matrix elements. Next, I had entered the elements of matrix B. After that, the result is displayed and the program is correctly executed. Okay. I had explained it clearly about what is meant by Strassen's matrix multiplication algorithm. Thank you.